Hello students, after completion of different chapters, that is alkane, halvarines, then phenols, ethers, alcohols, aldehydes, ketones, carboxylic acid. Next start a new chapter, that is nitrogen containing compounds. So nitrogen containing compounds are generally nitro compounds, cyanides, isocyanides, amides, amines, etc. Nitrogen is an important constituent of plant product, animal product as well as synthetic product. It is a constituent of proteins, then enzymes, hormones, also important constituents of drugs, different polymers, like this. So, in this way, nitrogen is an important constituent of organic compound, and here, especially we study about amines. So, what are amines? Amines are generally known as the alkyl or aryl derivatives of ammonia. You know, ammonia has 3 hydrogen atom, there is 1 lone pair of electron. If the hydrogen atom are substituted by alkyl groups or aryl groups, this is known as your amines. So, amines are the alkyl or aryl substituents of ammonia. These are the alkyl or aryl substituents of ammonia. If one hydrogen atom replaced by one alkyl group, I can write like this NHH. If 2 hydrogen atoms are replaced in ammonia, then R, N, R and H. And if 3 hydrogen atoms are replaced, then R, and R. So this is your different types of amines. Okay, so all these are, if the hydrogen atom here R may be alkyl group or aryl groups. So if hydrogen atoms are replaced by alkyl group or aryl group, these are called amines. Next come to what is the classification of amines. Classification. So amines are broadly classified into 3 types: primary amine, secondary amine and tertiary amine. You know, in alcohol, the OH group attached to the carbon atom. According to that, primary, secondary and tertiary alcohols are determined. But here, in case of amine, this classification is different. Here, how many number of hydrogen atoms of ammonia replaced by alkyl or aryl groups, according to that, this is classified as primary, secondary and tertiary amine. If 1 hydrogen atom is replaced by 1 alkyl or aryl group, this is called primary amine. If 2 hydrogen atom replaced by alkyl or aryl group, this is called secondary amine. And if 3 hydrogen atoms are replaced by alkyl or aryl group, then that is known as tertiary amine. So depending on the number of hydrogen atoms of ammonia replaced by alkyl or aryl groups, these are classified as primary, secondary and tertiary amines. Whether 1 hydrogen, 2 hydrogen or 3 hydrogen of ammonia replaced by alkyl or aryl groups, according to that, these are classified as primary, secondary and tertiary amines. Look at some examples. So you know N, H, this is ammonia. If 1 hydrogen atom replaced by alkyl group, then I can write R, N, H. So this is primary amine. This is primary amine. Here 1 alkyl group is replaced by hydrogen. If hydrogen is replaced by 1 alkyl group. And what is the functional group here? The functional group is NH2. The functional group is NH2. So this is the functional group. If 2 hydrogen atom replaced by alkyl group, then R, N, R dash and H. This is secondary amine. And what is the functional group here? NH. This is the functional group. To these two different alkyl or aryl groups substituted. To this alkyl or aryl group substituted. And if the 3 hydrogen atoms are replaced, then what is the N, R, R and R? Suppose R, R dash, R double dash. This is tertiary amine. And what is the functional group? N. So this is nitrogen is the functional group. Apart from this, there is another class of compound that is called ammonium salts. What is the ammonium salts? You know, in ammonium salt, that is N, H, 4 hydrogen atoms are there and they reach a positive charge. If in the ammonium salt, all the 4 hydrogen atoms are replaced by alkyl groups, then that is called your ammonium salt. Okay, for example, look here, R, N, R, plus. So this is ammonium salt. Let us see some examples of each case. What is primary, secondary, tertiary amine, and what are the different examples. So you know what is the functional group? NH2. What is the functional group? NH. What is the functional group? N. So look here, example. CH3 NH2, C2H5 NH2, C6H5 NH2. What are their names? I will tell you later. So this is NH2 group are there. So this is methylamine, ethylamine and aniline. So all these are primary amines. Here the functional group NH2. Okay. And another example here also I am writing CH, NH2, CH3. This is also a primary amine. Next come to secondary amine where functional group is NH and 2 alkyl groups or aryl groups are there. Example CH3, NH, CH3, CH3, NH, C2H5, CH3, NH, C6H5. What are their names? I will tell you later in nomenclature section. So this is your what? This is just these are secondary amines. So these are primary amines, these are secondary amines because the functional group is NH. Next come to examples of tertiary amine. CH3, N, CH3, CH3. So here the functional group is only nitrogen and 3 hydrogen atoms are replaced by 3 methyl group. Similarly, CH3, N, C2H5, C6H6. So this is C6H5. So these are your tertiary amines. So these are primary amines, secondary amines and tertiary amines. And what are the examples of some quaternary salts? Some quaternary salts are CH3, N, CH3, CH3, CH3 plus I minus. So here methyl group, here hydroxide group, here halogen or hydroxide groups are generally present. So these are the examples of some primary, secondary, tertiary amine along with ammonium salt. Next, these amines again classified depending on what are the types of groups are present. These are again classified into 2 types. One is your aliphatic amine, another your aromatic amine. So again, these are classified as aliphatic amines and another aromatic amines. So aliphatic amines means when 1, 2 or 3 alkyl groups are directly substituted to nitrogen atom. When 1, 2 or 3 alkyl groups if directly attached to nitrogen atom, then that are known as your aliphatic amines. That may be primary, secondary or tertiary. CH3NH2, CH3, CH2, NH2, CH3, NH, CH3, CH3, CH, NH2, CH3. All these are your aliphatic amines. Methylamine, ethylamine and methylamine and isopropylamine. All these are examples of aliphatic amines. Next, aromatic amines. Aromatic amines again classified into two types. One is aryl amine and another R-alkyl amine. So, aryl amines are those in which nitrogen atom is directly attached to the aromatic ring or aromatic nucleus. If the nitrogen atom directly attached to the aromatic ring, then 1, 2 or 3 aromatic ring, that is called your aryl amine. Look here, if this is benzene group, phenyl group and NH2, nitrogen directly attached to the aromatic ring. This is your aryl amine. Or another also I can write NH here. H. This is, same thing here written. So this is also known as your aryl amine. And another also I can write, that is, here suppose CH3 group, here NH2 group. So this is known as, these are known as your aryl amines, where nitrogen is directly attached to 1, 2 or 3 number of aromatic ring. And what is R-alkyl amines? R-alkyl amines are that where nitrogen is directly attached to the side chain of aromatic ring. To the side chain of aromatic ring, then that is known as your R-alkyl amine. Look your example. Suppose NH2 is attached to benzyl group. So side chain CH2, NH2, this is your R-alkyl amine. And another CH, NH2, CH3. So these are some examples of aliphatic amines and aromatic amines. Next, these amines are again classified as what? These amines again classified as simple amines and mixed amines. So what is this simple amine and mixed amines? Again these are classified as simple amines and mixed amines. So simple amines are those where all the alkyl or aryl groups are same, that are known as your simple amines. Generally this is in case considered in case of secondary and tertiary amine. So if all the alkyl groups are same, then this is known as your simple amine. CH3, NH, CH3, both alkyl groups. C2H5, NH, C2H5. These are examples of simple amines. If one of the alkyl group is different, then this is known as your mixed amines. This is generally considered for secondary amines and tertiary amines. Simple and mixed. Example, CH3, NH, C2H5. Different alkyl groups. Nitrogen here, C3H7, CH3, C2H5. So this is your mixed amines, where alkyl groups are different. This is mixed amines. If the alkyl groups are same, that is your simple amines. Next come to nomenclature of amines. So you know, in nomenclature there are two systems of naming. One is your common name system, another your IPAC system. So according to the common name systems, amines are named as alkyl amines or aminoalkanes. For amines, there are two systems of common name. One is alkyl amines or aminoalkanes. What is the largest part of alkane? You have to consider that, and before that you have to write the amino. Otherwise, you can write alkyl amines. So, amines are generally three types. One is primary, secondary, tertiary amines. In this way, this naming system is also different types. For primary amines, these are known as alkyl amines or aminoalkanes. And for secondary amines, these are known as alkyl amine. These are known as your alkyl amine. For secondary amine, known as alkyl amine, and these alkyl groups are generally written in alphabetical order. This is in alphabetical order. Which alkyl groups comes first in alphabetical order? That is written first. Alkyl amine, and this is known as your alkyl aminoalkane. And look here, if both the alkyl groups are same, then before writing the alkyl group, di is used. I can write dialkyl amine. And for tertiary amine, the naming system is like this. The naming system is alkyl amine. If all the alkyl groups are same, then I can write trialkyl amine. If two are same, dialkyl amine. So trialkyl amine. And when I write in this system, this is also known as alkyl aminoalkane. So these are the name how to write the common name of these compounds. Let us look some example of this common name system. First, primary amine, CH3NH2. So this is methyl group NH2. So this is known as your methyl amine. This is methylamine, also known as aminomethane. According to this system, aminomethane or methylamine. But very common is the naming of this common name is very commonly used. This type of naming, that is alkyl amines. So CH3NH2 methylamine. Similarly, C2H5NH2 known as ethylamine. Okay. Let us see some examples of this primary, secondary and tertiary amine. Okay, before going this primary, secondary, tertiary amine, how to name in common name system. Now let us know what is the rule to know the IPAC system, IPAC system. So according to IPAC system, these are known as alkanamine. These are known as alkanamine. Look here. So what happens here? Alkane minus E plus amine give rise to alkanamine. Okay. So primary system, this is known as your, for primary amine, this is known as your alkanamine. For primary, this is known as your alkanamine. For secondary, so the alkyl group is substituted at nitrogen atom. In this way, for secondary, this is known as your N-alkyl alkanamine. N-alkyl alkanamine. Remember, if more number of carbon atom is present in alkane system, then the position of this amine should be written before the suffix amine. Before the suffix amine, the position of this amine group should be written. Next, for tertiary amine, this is known as your N-alkyl alkanamine. N-alkyl alkanamine. If both the alkyl groups are same, then I can write N-dialkyl alkanamine. So in this way, you have to write the name of IPAC name of some amines. Let us look at some examples. CH3NH2, CH3CH2NH2, CH3CH2CH2NH2, CH3CH NH2 CH3 CH3 CH CH3 NH CH3 CH3 NH CH3 CH3 NH C2H5 CH3 N CH3 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 N C2H5 CH2 CH2 CH3. Okay, let us consider what are the common name and IPAC name of these compounds. So this is according to, first I am writing common name, then IUPAC name. So according to common name, this is known as your methylamine. And according to IUPAC name, known as methanamine. Similarly, this one, ethylamine and ethanamine. And this one, propyl, N-propyl, N-propyl amine. This is the common name. IUPAC name, propan 2 amine. Sorry, propan 1 amine. Because NH2 group is present at the lowest position, 1, 2, 3. So if more than 2 number of carbon atom are there, you have to write what is the position. Propan 1 amine. This one, common name isopropyl amine. And what is the IUPAC name? Propan 2 amine. This one, so this one is a secondary amine. We will discuss later. First some simple one, CH3 NHCH3, methyl 2 group. So common name dimethyl amine. And what is the IUPAC system? N-methyl. So methyl group substituted into nitrogen atom. N-methyl methanamine. Next, this one, methyl ethyl amine. So alphabetically ethyl comes first, then methyl, known as ethyl methyl amine. And according to IUPAC name system, so in IUPAC system, the larger number of carbon part is known as alkanamine and the smaller alkyl group is known as alkyl group or substituents. So N-methyl ethanamine. Next come to this one. So this is isopropyl group. This is methyl group. So isopropyl group and methyl group. So alphabetically isopropyl group comes from methyl groups, propyl, and this is propyl, this is methyl. So this propyl is isopropyl. So name of this compound is methyl isopropyl amine. Methyl isopropyl amine, common name. But according to IUPAC system, look here, this group methyl, this propyl, 3 number of carbon atom, and this is, we have to consider the long chain, 1, 2, 3, at 2 position, this group is present. Then, what is the name of this compound? 2 position is present. Okay, I can write name of this compound. N-methyl propan 2 amine. N-methyl propan 2 amine. This is the, so 1, 2, 3 at 2 position this amine is present, propan 2 amine, and methyl group substituent at nitrogen. So N-methyl propan 2 amine. Next, this one. So methyl. So common name system, trimethyl amine. And what is the IUPAC system? NN dimethyl methanamine. NN dimethyl methanamine. And what is the name of this compound? So here methyl, here ethyl, here propyl. So propanamine. So what is its IPAC system? What is its common name system? Methyl, ethyl, propyl. So in this way we can write name of this is ethyl and ethyl. So this is ethyl, methyl, propyl, amine. This is ethyl, methyl, propyl, amine. So ethyl, methyl, propyl, amine. Name of that compound is ethyl, methyl, propyl, amine. And what is the IPAC system? N-ethyl, N-methyl, propan, 1-amine. So this is the nomenclature of simple aliphatic. So after the name of aliphatic amines, now let us discuss how to name the aromatic amines. Simple, the aromatic amines, the suffix amine is used after the alkyl or aryl group, after the aryl group in common name system. So the simplest aromatic amine is aniline. Phenylamine, aniline. This is known as your aniline. So this aniline is also accepted by IPAC system. Generally in aromatic compounds, their common name is also accepted by IPAC system. Aniline, but according to the rule, its IPAC name should be, this is benzene ring and a next group is present. So last E of benzene is omitted and in that place amine is written. So the IPAC name of this is benzenamine. Benzene, E is omitted, then amine, benzenamine. Aniline is the common name as well as it is also accepted as IPAC system. If some substituents are present, then as usual the name followed in aliphatic compound, the aromatic amines have also the same way it is named. So look here, this is NHCH3. So this contain your more number of carbon atom, this contain less number of carbon atom. In this is the main branch, you can see this is the main branch. So this is the substituent. So name of this compound is, actually in common name system, N-methyl-aniline, and in IPAC system also it is known as N-methyl-aniline. We can say N-methyl-benzenamine also. And if NHCH2CH3, this is known as N-ethyl-aniline. If two substituents are present, NCH3, CH3, then NN dimethyl aniline. And if in this way present, so this is our alkyl group, this group is known as a benzyl. So benzyl group, benzyl amine. So according to common name system, this is known as your benzyl amine. But what is the IPAC name of this compound? You know, next group is not directly attached to this, it is attached to the side chain. So in this as a side chain, it contains one carbon atom. This is the derivative, this is known as the alkyl derivative of methyl group. That's why its IPAC name is phenyl methanamine. Phenyl methanamine. Similarly, CH2, CH2. So this is 1 and 2, 2-phenyl ethanamine. So 2 number of carbon, ethanamine, 2 position. We can say 2-phenyl ethan 1 amine, because you have to write the position of NH2 group. 2-phenyl ethanamine. Similarly, CH, CH3, NH2. So here also NH2 group is directly not linked with this nucleus, benzene nucleus. In this is also known as the derivative of this. So name of this compound is 1-phenyl ethan 1 amine. And let us now look some substituted amines. This is NH2 and CH3 group present. So these positions are ortho to each other. You know, these two positions are ortho, these two are meta, this is your para. So methyl group is present, NH2 group is there. So if CH3 group is attached to this, CH3 group is substituted in aniline, then this is known as your toluidine. According to common name system, known as toluidine. So as it is present at ortho position, this is known as your orthotoluidine. And what is the IUPAC name of this compound? This is 1 position, this is 2 position, 2-methyl aniline. Similarly, NH2 CH3. This is known as your M-toluidine, also known as 3-methyl aniline. And NH2 CH3. This is known as P-toluidine, also known as 4-methyl aniline. So in this way you have to name some aromatic compounds. So after completion of nomenclature, next come to isomerism. So what is isomerism? When the same molecular formula represents two or more compounds which have different physical and chemical properties, then such compounds are called isomers, and this phenomenon is called isomerism. So amines generally exhibit structural isomerism. So there are different, it can exhibit different structural isomerism like chain isomerism, position isomerism, functional isomerism, metamerism. So let's come to chain isomerism. So amines, aliphatic amines, generally which contain 4 or more number of carbon atoms that can exhibit chain isomerism. So what is chain isomerism? When same molecular formula represents 2 or more compounds which have different carbon skeleton or carbon chain, either straight chain or branch chain, then such compounds are called chain isomers, and this phenomenon is called chain isomerism. Let us consider the example of C4H11N. So, this can be represented CH3, CH2, CH2, NH2. Same molecular formula 1, 2, 3, 4. Hydrogen is 11 and nitrogen. So, what is this compound? This is butane 1 amine, and another CH3, CH, CH3, CH2, NH2. What is the name of this compound? 2-methyl propan 1 amine. These two are chain isomer of each other. This is a straight chain compound and this is a branch chain compound. Look in chain isomerism, then the word root is changed. This is butane 1 amine. This is propan 1 amine. These two are chain isomer of each other. Next come to position isomerism. So what is position isomerism? When the same molecular formula represents two or more compounds, when the same molecular formula represents two or more compounds which have different positions of double bond, triple bond or functional group, then such compounds are called position isomers, and this phenomenon is known as position isomerism. So for position isomerism, the amine should contain at least 3 number of carbon atom, 3 or more number of carbon atom. Okay, look at the example. CH3, CH2, CH2, NH2. What is this? This is propan 1 amine. Position of NH2 is 1 position. CH3, CH, NH2, CH3. What is this? This is propan 2 amine. Position of amine group is 2. So these two are position isomer of each other. Similarly, CH3, CH2, 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 NH2. What is this compound? Butane 1 amine, and another CH3, CH2, CH, NH2, CH3. What is the name of this compound? Butane 2 amine. So same molecular formula C4H11N, but that represents two compounds which have different positions of this functional group NH2 group. Here position 1, here position 2. So these are the examples of position isomerism. Similarly, the aromatic compound, the substituted aromatic amines also exhibit position isomerism. Look here, I have told you about toluidine, NH2, CH3, ortho toluidine. Same molecular formula, meta toluidine. Para. So aromatic amines, substituted aromatic amines generally exhibit position isomerism. Next come to functional isomerism. So, what is functional isomerism? When the same molecular formula represents two or more compounds which have different functional groups, then such compounds are called functional isomers, and this phenomenon is called functional isomerism. So amines also exhibit functional isomerism. Actually, the primary, secondary and tertiary amines, these are functional isomers of each other. Same, suppose I consider about C3H9N. So this represents three functional isomers. Look here, CH3, CH2, CH2, NH2. So what is this? This is known as your propan 1 amine. This is primary amine. CH3, CH2, NH, CH3. What is this? N-methyl ethanamine. That is a secondary amine. And N, CH3, CH3, CH3. What is this? NN dimethyl methanamine. This is a tertiary amine. These have different physical and chemical properties. In this way, these are functional isomers of each other. So, amines exhibit functional isomerism. So, primary, secondary, tertiary amines, these are functional isomers of each other. Next, come to metamerism. So, metamerism generally exhibited by secondary amines. Other amines generally do not exhibit metamerism. Generally, it is exhibited by secondary amines. Same come to C4H11N. That representative compound, look here, CH3, CH2, NH, CH2, CH3 and CH3, NH, CH2, CH2, CH3. Another CH3, NH, CH, CH3, CH3. What is metamerism? When same molecular formula represents two or more compounds which have different alkyl groups around the functional group, on both sides of the functional group, then such compounds are called metamer of each other, and this phenomenon is called metamerism. C4H11N, all are representing your same functional group, that is your secondary amine. And what are the name of this compound? One is N-ethyl ethanamine. And what is this? This is N-methyl propanamine. And this is propan 1 amine. And this is N-methyl propan 2 amine. So these are metamer of each other because it is the functional group, and around the functional group, in each case, different alkyl groups are present. Here ethyl, here methyl N-propyl, and here methyl isopropyl. In this way, these are metamers of each other. Along this, some amines which have chiral center that can also exhibit optical isomerism. Next, what is the structure of amines? Actually, structure means, what is the structure of amines? In amines like ammonia, the nitrogen atom is sp3 hybridized. Nitrogen atom is sp3 hybridized. So this is L pair. So that means it has 4 sp3 hybrid orbital. Among the 4 sp3 hybrid orbital, 3 sp3 hybrid orbital form bond with hydrogen or alkyl group, and there is one sp3 hybrid orbital which contain lone pair of electron. So R, H and nitrogen R and R. So this is primary amine, secondary amine, tertiary amine. All cases the nitrogen atom is sp3 hybridized and all have pyramidal shape. The bond angle is less than that of original tetrahedral angle due to presence of lone pair and bond pair of electron. But in case of tertiary amine, the bond angle slightly increases due to presence of steric hindrance than that of primary amine and secondary amine. So this is all about the introduction of amines.